Hi and Assalamualaikum. In today's video, our group will be present about application of system of linear equation, which is chemical equation. So let me introduce my team members, which is Nur Farhana Nabila binti Saharuddin, Nur Atika Nadira binti Muhammad Samzuli, Nur Munira binti Abdullah, and Siti Khadijah binti Muhammad Shukri. Introduction. First, the definition Gaussian elimination method is the procedure for reducing a matrix to a raw echelon form by performing elementary raw operation. Next, the definition Gauss-Jordan elimination method is the procedure for reducing a matrix to a reduced raw echelon form by performing elementary raw operation. Moreover, the definition inverse of matrix is n by n matrix is called invertible if there is exists n by n matrix to a raw echelon form by performing raw echelon form. Last but not least, the definition Cramer's rule is a method to solve system of n linear equation with n variable.
For our case study today, our group chose chemical equation as our title for this project. Boron sulfate reacts violently with water to form boric acid and hydrogen sulfate gas, which is the smell of rotten eggs. Unbalanced equation is down below. For each compound, construct a vector that lists the number of atoms of boron, sulfur, hydrogen, and oxygen. Then balance the chemical equation for the reaction between boron sulfate and water to produce boric acid and hydrogen sulfate by using Gaussian elimination method.
Purpose of study for this group project is to convert the problem into a system of linear equation. To solve a linear system, use Gaussian elimination method, and also to balance the chemical equation using vector.
So we move to the methodology for the step 1. Since equation involve 4 types of atom, boron, sulfur, hydrogen, and oxygen, construct a vector in R3 for each reactant and product. In that list, the number of atoms per molecule as follows. We have boron sulfur plus water will produce boric acid and hydrogen sulfate. For the boron sulfate, we have 2 boron, 3 sulfur, 0 hydrogen, and 0 oxygen. Water, we have 0 boron, 0 sulfur, 2 hydrogen, and 1 oxygen. For the boric acid, we have 1 boron, 0 sulfur, 3 hydrogen, and 3 oxygen. And for the last one is hydrogen sulfur, we have 0 boron, 1 sulfur, 2 hydrogen, and 0 oxygen. The arrangement of the atom, it doesn't matter, but make it consistently until the solution have been done. Step 2. To balance the equation, the coefficient x1, x2, x3, and x4 must be satisfied. For the x1, 2, 3, 0, 0 plus x2, 0, 0, 2, 1 equals to x3, 1, 0, 3, 3 and plus x4, 0, 1, 2, 0. Next, step 3. To solve, move all the terms to the left, means changing the sign in the third and the fourth vector. For x1, 2, 3, 0, 0 plus x2, 0, 0, 2, 1 plus
x3, negative 1, 0, negative 3, negative 3 plus x4, 0, negative 1, negative 2, 0 equals to 0, 0, 0, 0.
For the step 4, change the equation into a system of linear equation as follows, which is 2x1 minus x3 equals to 0, 3x1 minus x4 equals to 0, 2x2 minus 3x3 minus 2x4 equals to 0, and x2 minus 3x3 equals to 0. Next, for the step 5, transform it to the matrix equation, which is for the row 1, 2x1 plus 0x2 minus x3 plus 0x4. For the row 2, 3x1 plus 0x2 plus 0x3 minus x4. For the row 3, 0x
0x1 plus 2x2 minus 3x3 minus 2x4, and for the row 4, 0x1 plus x2 minus 3x3 plus 0x4. And step 6, change the matrix equation to the augmented matrix.
For the 7th step, half multiply with row 1 and change row 1. And the result is 1, 0, negative 1 over 2, and 0. And for the step 8, row 2 minus 3 and multiply with row 1 and change row 2. And the result will be 0, 0, 3 over 2 and negative 1. For the step 9, change row 2 and row 4.
For step 10, row 3 will minus 2 multiply with row 1 and change row 3. For step 11, 1 over 3 multiply with row 3 and change row 3. For step 12, row 4 will minus with 3 over 2 multiply with row 3 and change row 4.
By using Gaussian elimination method, we got x1 minus 1 over 2 x3 equals to 0, x2 minus 3 x3 equals to 0, and the last one would be x3 minus 2 over 3 x4 equals to 0. From step 14, we just clarify that x4 is our free variable and x4 is equals to p, which is any real number. For the step 15, we need to find x3 first, which is x3 equals to 2 over 3 x4. And we know that x4 is equals to p, which is the any real number, and the result will be x3 equals to 2 over 3 p. And for the next one is x2, which is equal to 3x3, and from what we got earlier, which is x3 is 2 over 3p, we just need to replace the x3 with 2 over 3p, and what we got is x2 is equals to p, equals to 2p. And lastly, x1 equals to 1 over 2 x3. What we know, x3 is equals to 2 over 3p. We just replace the x3 and the result will be x1 equals to 1 over 3p.
For result and discussion, rule reduction of the augmented matrix for this equation lead to system that has many solutions. For x1, we have 1 over 3 x4. For x2, we have 2 x4. x3, we have 2 over 3 x4 with x4 is free. Since the coefficient in chemical equation must be integer, take x4 as a 3, in which case x1 equal to 1, x2 equal to 6, and x3 equal to 2. So the balance equation is 1 molecule boron sulfate plus 6 molecule of water will produce 2 boric acids and 3 hydrogen sulfate.
Conclusion: after performing the Gaussian elimination to balance the chemical equation for the reaction between the boron sulfide and water, we can conclude that the balance equation ensures that the number of atoms for each element is the same both sides of the reaction. It represents the chemical reaction where boron sulfide reacts with water to produce boric acid and hydrogen sulfide. Thus, we have successfully reaching all the objectives in this case study, also prove that using the system linear of equation.
Thank you for watching this video. Bye!